Okay, so today we're going to do identity and inverse matrices. So before we jump into identity matrices, let's make sure we understand what an identity is. So just like the word identity means like who you are. So if we're talking about math, identity is what we need to get back the original. So you've learned about an additive identity and a multiplicative identity. Just with like basic numbers. So if I had a 3 and I wanted to add something to it to get 3 back, then I would have to add 0. If I had a 3 and I wanted to multiply by something and get the 3 back, then I would use a 1. All right, so with matrices, we're going to have the same concept. We're going to stick with the multiplicative identity. What is it that I'm going to multiply that matrix by to get the exact same matrix back? So let's talk about that. So if I give you this matrix and I want the same matrix back, what do you think we would need to multiply by? All right, so you, I assume, could come up with some form of like a 1, right? So remember when you're multiplying matrices, this is a 3 by 2, and we end up with a 3 by 2. So remember that we discussed that the columns of the first have to match the rows of the second when we're multiplying. So this has to be a 2 by something. And we've also discussed that these outside numbers, the rows of the first and the columns of the second, will give you the dimensions of the answer. So that tells me, since I'm going to end up with a 3 by 2, that I have to have a 2 here. So we know that this matrix that we're multiplying by is going to have to be a 2 by 2. And when I'm multiplying this row by this column, I want to be able to get a 1. So I need 1 to stay 1 and 7 to go away, if that kind of makes sense. So I can do a 1 times a 1 and a 7 times a 0. All right, so if we think about what does this column need to be, well, to get a 7 here, if I do this row times this column, then I would need 1 to go away. So 1 times 0 and 7 to stay, so 7 times 1. So that would give me, this is what I need to be the identity matrix. And identity matrices are all going to have the same little pattern. They're going to be a square matrix with 1s on this diagonal and 0s everywhere else. All right, so I'm going to clean this off and go ahead and work through all of the multiplication so that you see that it really does work for the whole thing. All right, so here we go. You've already watched a video on multiplying matrices, so I'm going to explain what I'm doing as I'm going, but I'm not going to color code and belabor it too much. Okay, so we do this row times this column. That gives me 1 times 1 plus 7 times 0, which gives me the 1. If I do the first row by the second column, that gives me 1 times 0 plus 7 times 1, which gives me the 7. When I do this row times this column, that's negative 3 times 1 plus 4 times 0. So that would give me the negative 3. Then I do that row times the second column. So negative 3 times 0 plus 4 times 1. So that's 0, that's 4. All right, now it's the bottom row's turn. Bottom row times the first column gives me 2. And bottom row times second column gives me 0. All right, so you can see that if I take this matrix and I multiply by this identity matrix, I get the same matrix back. All right, so our job now is, first of all, can you just tell me an identity matrix? If I asked you for a 2 by 2 or a 3 by 3 or like a 10 by 10 identity matrix. Remember I just said that they all kind of have something in common. they're going to have ones on the diagonal and zeros everywhere else. So for a 3 by 3, we're going to have a 1 here, a 1 here, a 1 here. And then the rest of these are filled in with zeros. So for a 4 by 4, you would have a 1 with 3 zeros. And then it would be 0, 1, 0, 0. Then 0, 0, 1, 0. And then 0, 0, 0, 1. All right, so I could ask you for the 10 by 10, and it would be the same thing. You would need 10 rows, 10 columns. Make sure you have ones on the diagonal, but everybody else is zeros. Okay, so an identity matrix is helpful because it is going to give you back what you started with. Okay, so if I want to use that concept, we can find inverse matrices also. And so we know that, and it's going to come like to pass at the end of this lesson, like how the identity and the inverse kind of interact. But we know that if we multiply something in its inverse, or like if we do two inverse operations like multiply and divide, then we get 1, or we get the identity. So that's going to come into play on our very last example. But for right now, we just need to talk about what is an inverse matrix. All right, so I kind of just foreshadowed, like if we know we are multiplying, then the inverse of that would be to divide. It's what we can use to undo. So that's why we need to know inverse matrices. It's how do you get that identity back? How do you get just 1 if you have matrices? So to find an inverse matrix, there's a couple of things that have to be there before we can even start. First of all, in order for a matrix to have an inverse, it has to be square. So I can only find the inverse of a 2 by 2 or a 3 by 3 or a 4 by 4 or a 20 by 20. I cannot find the inverse of a 3 by 2. All right, for a matrix to have an inverse, its determinant cannot equal 0. All right, so the reason for that is there's a formula that you can use for a 2 by 2. If it's anything bigger than a 2 by 2, there's not really a formula. There is a way to do it by hand using some operations that we haven't shown y'all. You can look in your textbook at the first section of this chapter, and it kind of goes through that operation. But my point is, I'm going to show you how to do it without going through lots and lots of steps, which is the way that you would do it by hand for anything other than a 2 by 2. For a 2 by 2, we have a short little formula, which we can use and we're going to use. But for a 3 by 3 or bigger than that, I'll show you how your calculator will do it for you. Okay, so this is our formula. And so if you look at the formula, you see that this right here is the determinant. If I multiply this diagonal minus this diagonal, like Ms. Hall showed in the last video, then you can see that that's the determinant. So this is the determinant. All right, and if that was 0, then we would be undefined, so there would not be an inverse. All right, so if you're trying to find the inverse, remember that undefined is an option. It doesn't have to have an inverse. Not every matrix will have one. Not even every square matrix is going to have an inverse. All right, so the formula is to get the inverse of a 2 by 2, we're going to do 1 over the determinant as a scalar multiplied by our matrix, but we're going to kind of rearrange it and change some stuff up. So we're going to take this diagonal and switch those numbers. So instead of having an A and a D, we're going to have a D here and an A here. And then this diagonal, the signs change. All right, so pause and write that down if you need to, and then we will do an example. All right, so if I give you this as A, to find the inverse of A, you are going to do 1 over the determinant. So remember the determinant is this diagonal, so 2 times 4, minus this diagonal, so negative 3 times 6. All right, and then you're going to multiply that by your matrix, but we're going to change it up a bit. I forgot I made that so big. So this diagonal, they switch places. So 4 here, 2 here. This diagonal, we switch the signs. So negative 6 here, positive 3 here. All right, so this works out to be, this was a 4. All right, so that's 8. And then this would be negative 18, but minus a negative 18, so plus. So 8 plus 18 is 26. All right, and then we just, it's like distribute this multiplies by everybody in here. So 4 over 26 would become 2/13. Negative 6 over 26 would become negative 3/13. 3 over 26 doesn't reduce, so just 3 over 26. And 2 over 26 becomes 1/13. So will an inverse always have fractions in it? Not always, but the majority of the time, yes, because you're going to multiply a fraction times a bunch of numbers. You will likely get a fraction. But it could work out to be integers in there. Okay, so that's how you find the inverse of a 2 by 2. We're going to do 1 over the determinant. And then we switch the numbers on this diagonal. And we change the signs on this one. Okay, so to find the inverse of a 3 by 3. Again, there is a process that you can go through, but we're not going to worry with that. We're going to just use our calculator. All right, so with your graphing calculator, and remember if you don't have one of those at home, you can download this app, or there are graphing calculators on your cell phones that are free downloads. Also, you have GeoGebra, that's a free thing that you can use through the internet. All right, so for matrices, there's a couple of ways to get to them. So we have these, if you have the new operating system on your graphing calculator, if you have your own, if you have an older one, it may not have this option. You can do alpha zoom, and it will let you type in a matrix. You can tell it what you want the dimensions to be and just type in your matrix. And then your other option is to, if you see right here above this x to the -1 button, it says matrix. So if you'll do second and that button, it brings you up to some matrices. We want to type things in, so we have to go over to edit and choose the one we want to type into. And then again, tell it the dimension. So whichever way works for you. This is a 3 by 3, so we're going to tell it we want a 3 by 3. And then it sets us up a 3 by 3, and we just type in our elements. So 7, 4, -1, 3, 0, -2, 0, 8, 1. All right, I'm hitting enter, but I think if you do the alpha zoom and try to type it in, you have to use the arrow keys, because enter enters it as that's your matrix, like you're done. So if you go to second matrix, you can hit enter to move from one element to the other. If you do alpha zoom, you have to use the arrow keys. Okay, so the bad thing about using the matrix option is that there's more steps. So to get off of this, we have to do second, quit, and then we have to go back and tell it that we want matrix A that we just typed in. And then we do this little -1 for the inverse. And when you hit enter, you get all of these fun decimals. But if you'll go to math and do enter, like I want a fraction, and then yes, I really do. then it'll give you fractions. So we know that A inverse is equal to, I'm going to pull it back up so you can look at it. All right, now I have it written down on a piece of paper, so I'm going to write it down up here for you, but my calculator is going to go away. All right, so we have 4 over 19, 4/19, negative 3/19, negative 2/19, negative 3/76, 7/76, 11/76, 6/19, negative 4/19, and negative 3/19. And that is our inverse. Okay. All right, so I'm going to go back through and show you the other way for those of you, because it's less steps. So if I go with alpha zoom, and then I can tell it that I want a 3. Okay, I have to use my arrow keys. Yeah, okay. I don't use this way very often, so y'all sorry. Use your arrow keys to get to the numbers you want and hit enter. So now we told the calculator we want a 3/3, so arrow back down to OK. And it gives you your matrix. And again, you have to use the arrow keys to go from one element to the next. I meant for that to be an 8. All right, but the nice thing about this is once you have it typed in, it's already there on your calculator screen. So I can just hit this x to the -1 to give the little inverse symbol and then hit enter. And it still gives me the decimals. So remember, I can do math, enter, enter, and it will give me fractions. So I've showed you 2 ways to do the same thing because the calculator has the old way of doing it and then the new operating system way of doing it. So whichever way works on your calculator or whichever way you prefer, you can use. Okay, so since I've introduced the calculator, I'm going to show you how you can do some of the things we've already learned with the calculator. So as far as inverses go, I've shown you how to find a 2x2 by hand, and I've shown you how to find a 3x3 with the calculator. Remember, 2x2s you can do by hand easily. There's a little formula. For a 3x3 or bigger, then we're just going to use our calculator because there's not a quick formula if we're going to try to do it by hand. What's fun about inverses is that just like with multiplication, like I can take a 3 and multiply by its multiplicative inverse of 1/3, and I get 1, the identity. So with matrices, if you multiply a matrix and its inverse, you get the identity matrix, you get 1. So inverses are a nice way of undoing a matrix if we have an equation, which is what the last problem is going to be for today's lesson. But for right now, we're going to backtrack and we're going to talk about multiplying and finding determinants, but I'm going to show you how your calculator will do those for you. All right, so now that you know how to do it by hand, we'll let you use your calculator. So if I have these 2 matrices, again, there's 2 ways of doing it, whether you want to use the old way or the new way for the calculator. So we have alpha zoom, and you tell it what your dimensions are. It'll bring up a matrix, you type it in, and then you can bring up the other one. You can also go to, you can go to second matrix, and you'll have to go over to edit, enter it in, do second quit, and then go back to matrix, over to edit, and put in the other one. So there's a lot more steps doing it that way, but I feel like some of you may need that shown. So I'm going to show you this both ways. All right, so if we do alpha zoom, then to do a, what do we have here? A 2x3. So we're going to go to the 2, and the 3 is fine. So here we go. We can put in that it's a 1, 2, 3, 4, 5, 6. Y'all, when I picked this problem, I didn't even notice that the numbers were like that. It's kind of hilarious. Okay, then we're going to say I want to multiply by, and let's go back to alpha zoom so that we can get a matrix. And this time we want it to be a 3 by 2. All right, and this is 7, 8, 9, 10, 11, 12. All right, and then you just hit enter, and it tells you that when you multiply those, you get 58, 64, 139, 154, 64, 139, and 154. All right, so again, if you like this way and you have this calculator with this new operating system, then you don't have to watch me work the other way. You can fast forward a little bit. So if I want to do the second matrix way, I have to go over to edit, tell the calculator that I'm putting in a 2 by 3, and then type in my numbers for my elements. And then second quit to make that go away and save. And then we do second matrix again, over to edit and go down to B. And then tell the calculator that it's a 3 by 2. And then put in those elements. All right, second quit to make that go away and save. And then we go back to matrix, and this time we're going to use them. So we stay on names and we say I want number 1 or matrix A times, and then back to matrix and tell it to do B, and then it gives you your answer. All right, so something else that we can do with the calculator is find the determinant. All right, so if I want you to find the determinant, remember that's what these straight bars mean. That's your clue that the determinant is what they're asking for. All right, so to tell the calculator you want to do the determinant, you have to go to second matrix and then go over to math, and it will do all kinds of things for you. We're wanting the determinant, so we're going to choose number 1. And then you just tell it which matrix you want the determinant of. All right, so to do the alpha zoom way, you have to get this determinant on your screen, and then we're going to tell the calculator that we want it to be a 3 by 3. And it will put it in there, and then we have to type in our values. Remember to use the arrow if you're doing this method. All right, 4, 2, 6, negative 10, 5, 5, 8, 5, 5. Okay, and then you can close a parenthesis, or it doesn't really matter because you're done. Hit enter. You only have to edit once. And you get negative 360. All right, so if we're doing the second matrix way, we're going to go second matrix, go over to edit first, and type in your matrix. So this is a 3 by 3, and it's elements are 4, 2, 6, negative 10, 5, 5, 8, 5, 5. All right, so second quit, it'll go away and save, and we go back to matrix, over to math, we want the determinant, and then back to matrix, and we want the determinant of what we put into A. And it gives us our negative 360. I think I just said 36 a while ago. I don't know. Anyway, negative 360 is the determinant of that matrix. All right, so that's how you can use your calculator if you're taking the ACT and you need things to be faster, if you can remember where the buttons are. and you're careful to not miss any negatives and things like that, then using the calculator on the ACT is a good thing. It helps things go a little quicker, and you're less likely to make careless mistakes as long as you're careful about what you type in. All right, so our last example, which kind of puts all of the things we've talked about together. If I want you to solve a matrix equation, then I'm wanting you to figure out, what is this matrix X? So if I do this matrix times another matrix, I get this matrix. Well, what is that matrix? Well, if this was an equation like just 2x equals 6, then you know to get rid of multiply, you divide, right? Well, technically, we're multiplying by the multiplicative inverse. When we divide by 2, we're really multiplying by 1/2, right? So that's why we get x is 3. This works out to be the identity of 1, the multiplicative identity of 1. And then over here, we get a 3. All right, so using that same concept, what I want to be able to do is get this matrix to go away. So I have to multiply it by its inverse. So if we call this matrix A and this matrix B, because we're going to use our calculator, then to get rid of matrix A, to make this become just a 1, or the identity matrix, which is just 1, then I need to multiply by its, what did I just click? Oh, I thought I clicked the blue, but I clicked this dotted line. That was weird. Sorry, y'all. I need to multiply A by its inverse in order to get the identity here and just be left with X, which represents a matrix. All right, so over here, I'm also going to multiply by the inverse. And remember, we learned that matrix multiplication is not commutative. So remember that we always multiply the inverse in the front. Okay, so to solve this, we multiply A inverse by A, and that gives me the identity, which leaves me with just this X. And then over here, I do A inverse times B, and it gives me this. All right, so again, 2 ways of doing it. You, with your calculator, you can type this into A and type this into B, and literally put A inverse times B on your screen and hit enter. Or you can do this guy with a little -1 times this one. All right, and I'm going to go through and show you both ways. All right, so for the first way, if we are doing alpha zoom to get to matrix, then we're going to type this on our screen. So we're going to go tell the calculator that we want a 2 by 2 and put in our elements of 7, -2, 3, 4. And then we want the inverse of that times, and then we need another matrix that's also a 2 by 2, and it is the -2. See, y'all, I told you, if you hit enter, it completely messes everything up. So let's go back. All right, -2, -1, arrow for 5. All right, now that it's all typed in there, we hit enter. And again, we can do math enter to turn those decimals into fractions. And we see that X is equal to the matrix 0, 3/17, 1, 19/17. So if I take this matrix and I multiply by this matrix, I should get this matrix. All right, so if we're using the second matrix version of this, then what I'm going to do is, I don't know why I made that small, do A inverse times B. So I'm going to slide this way over here so I can see what I got going on. Okay, so we're going to go second matrix over to edit. tell it we want a 2 by 2, type in matrix A, that should be a 4. Okay, second quit, it saves it and takes it away. Go back to matrix, over to edit, down to B, and tell it that we want B to be a 2 by 2. So we have -2, -1, 4, 5. Second quit, it saves it and takes it away. We go back to matrix and we tell it, we stay under name, tell it we want A. Then we want the inverse of that. So x to the -1 puts our little -1 exponent up there that says inverse. And then times back to matrix and grab 2 or B. And when you hit enter and then math enter, it gives you that same answer. Okay, so now you know how to find the identity matrix and how to find the inverse matrix, why they're helpful, and how to use your calculator to do some of the things that we have learned. Make sure that you ask questions if you have them.